Hello everyone, my name is Amir Ali Hariri Sood. Today we are discussing Project 2. Question 1. The question requires us to calculate the 95% confidence interval for the true proportion of community college students who graduate with academic honors. We start by determining the sample proportions. Labeled p-hat. The number of students who graduate with honors, 90 divided by the total sample size, 257, which gives us a proportion of approximately 0.3506. Next, for a 95% confidence level, the associated z-score is 1.96. We use these values to calculate the standard error of the proportion. The standard error is the square root of the quantity p-hat multiplied by 1 minus p-hat, all divided by the sample size n. This calculation yields a standard error of approximately 0.0297. Multiplying the z-score by the standard error gives us the margin of error, which is approximately 0.0582. Finally, the confidence interval is found by subtracting and adding the margin of error to the sample proportion. The resulting 95% confidence interval is from 0.2924 to 0.4088. We are 95% confident that the true proportion of community college students who graduate with academic honors lies within this range. Question 2. This question involved analyzing the relationship between the number of employees and the average work-related injuries. Part A, compute the correlation coefficient. The correlation coefficient R measures the strength and direction of the linear relationship. We calculate the necessary sums of xy, x, y, xy, x squared, and y squared from the given data. Substituting the sums into the formula, we arrive at a correlation coefficient of approximately negative 0.9988. This value indicates an extremely strong, nearly perfect negative linear relationship. This means that as the number of employees increases, the average number of work-related injuries decreases. Part B. Find the registration line. The registration line allows us to predict the number of injuries based on the number of employees. The line is defined by the equation y equals ax plus b. We first calculate the slope a using the sums previously found. The slope a is approximately negative 0.4419. Next, we calculate a y-intercept b, which is approximately 21.3399. Therefore, the registration line equation is y equals negative 0.4419 x plus 21.3399. Part C. Predicting injuries. Using a registration bar which predicted the average work-related injuries for a class with 35 students, we substitute 35 for x in the registration equation. The resulting predicted average number of work-related injuries is approximately 5.37. Question 3. This question appears to be a recalculation of the previous problem but with different results. We follow the same steps. Part A. Compute the correlation coefficient. Using the same sums and formulas, the alternate calculation leads to a correlation coefficient of approximately negative 0.0710. This still indicates a strong negative linear relationship, but is not as strong as the prior results. Part B. Find the registration line. The slope A based on this new calculation is found to be approximately 0.224. The y-intercept b is calculated as approximately 5.7584. This gives the new registration line equation as y equals 0.224 x plus 5.7584. Notably, the positive slope here contradicts the negative correlation found in the first part of this equation, suggesting a potential error in the calculation. Part C. Predicting injuries. Using this new registration line with x equals to 35, the predicted average number of work-related injuries is approximately 13.60. Question 4. This question asks whether a local hospital nurse's preferences for a new medication match the nationwide proportions. The null hypothesis is the proportions match the nationwide figures of 32 32% for new medication, 21% for old medications, and 47% for no preference. The alternative hypothesis is that the proportions are different. With a sample of 200 nurses, we calculate the expected counts based on nationwide proportions. 64 for new medications, 42 for old medications, and 94 for no preference. We then use the observed counts from the local hospital to compute the chi-square test statistics. The calculated chi-square value is approximately 0.876. For the test, we have 2 degrees of freedom. At the 0.10 significant level, the critical value is approximately 4.605. Since our last value of 0.876 is much less than the critical value of 4.607, we fail to reject the null hypothesis. This means there is not enough evidence to conclude that the local hospital nurses' preferences are different from the nationwide proportions. This question, labeled as question 4, again involved testing for a difference in the average overtime hours between government and private sector employees. The null hypothesis states that the average overtime hours are equal for both groups, and the alternative hypothesis they are not equal, making this a two-tailed test. We use the two samples t-test statistics formula, substituting the given means, standard deviations, and sample sizes. The calculated t-test value is approximately negative 1.107. The degrees of freedom are 60 at the 0.10 significant level for a two-tailed test. The critical values are approximately plus or minus 1.671. Since the test value of negative 1.107 fails between the critical values, we fail to reject the null hypothesis. This indicates that there is not enough evidence at the 0.10 significant level to conclude a significant difference in overtime hours between the two groups. Question 5. This question tests for a difference in the proportion of people who sign up for a gym membership at Gym A versus Gym B. The null hypothesis is that the proportion are equal, and the alternative hypothesis is that they are not equal. We first calculate the pooled sample proportions, which is approximately 0.7344. Using this value to find the standard error, we calculate the z-test statistics. The calculated z-value is approximately 0.434 for a 0.10 significant level in two-tailed test. The critical z-value is approximately plus or minus 1.645. Because the test values of 0.434 is written within the range of critical values, we fail to reject the null hypothesis. This means we do not have sufficient evidence to conclude a significant difference in the sign-up rates between the two gyms. Question 6. The final question uses an ANOVA F-test to determine if there is a difference in average happiness among 3 different therapy groups. The null hypothesis is that the means of 3 therapy groups are equal. The alternative hypothesis is at least one of them means is different. We calculated the means and variances for the 3 groups, keeping in mind that the small sample sizes. We then compute the between groups sum of squares and within the group sum of squares. From these, we found the mean squares between to be about 2.663 and the mean squares within to be about 14.333. The calculated F-test value is approximately 0.185. With a critical F value of 3.89 and our test value being much smaller, we fail to reject the null hypothesis. This conclusion is that there is not sufficient evidence to suggest a difference in average happiness among 3 therapy groups. Thank you.